Okay, we left off with the formation of antibodies, defense, as one of the purposes of proteins or functions. The next one is regulation. So hormones, not all of them, some hormones are lipids, but the regulation of your body, several of them are hormones are intracellular messengers, insulin and growth hormone. Growth hormone is a pretty important thing, and it turns out these pygmies in the Congo Basin have a malfunctioning growth hormone. It's not the right shape, and we'll see those things in a second, how that works. It's not the right three-dimensional shape, and so they don't grow past a certain height. The next one is motion. So it turns out proteins are these little guys that are contracting and making things move along using ATP at the smallest level with actin and myosin. And let's talk now what the building blocks are. So we talked about the purposes and what they do. Now, the protein monomer, one part, is an amino acid. And that's created out of an amino group, our carboxylic acid group, I cannot speak today, and then our carbon hooking it together. And so, what process is used to build these? Bingo! We take out water, same, dehydration. All right, amino acids are the building blocks. So there are 20 different amino acids joined by what? Dehydration to form a peptide bond. So a peptide are two or more amino acids, and a polypeptide is a chain of more. And the sequence that we put together, that first row, is what determines the 3D shape of a protein. This is all very concrete. The 3D shape makes it do what it does. So it's similar to letters of the alphabet that go together to make words, then go together to make sentences. Primary structure. Then, of course, we go to secondary structure when we have a pleated sheet or a helix. So they start pleating up and forming hydrogen bonds across. Remember, those are that can hook and unhook pretty easily. Well, this is how easily they unhook. Hot hair irons, like if you're straightening your hair or curling your hair, what that heat does is it breaks the hydrogen bonds in this 3D formation and hooks together in the new form that you wanted, either straight or curly. Then tertiary, number 3. Now we have a globular shape, I can't speak today, going on. So instead of just hydrogen bonds, we now have covalent bonding between our groups. Enzymes do this, and that is why your body temperature and pH has to stay in a certain range, or your enzymes will uncoil, otherwise known as denatured. What's a good example of that? Egg white. Egg white's pure protein. Almost. And so when you crack it out of the egg, it's all gross looking and kind of mucousy. Then when you add heat, it turns white. What you've done is broken down, denatured it, added heat, broke all those bonds, and it uncoiled. And now it's a completely different product. And it will not do what it used to be able to do. So sometimes it goes to quaternary, the 4th level. Only very few do, but that means there's more than one polypeptide chain hooked together. But hemoglobin, that carries the oxygen in your blood, has 4 polypeptide chains hooked together and structured. So then you get to that level. Oops, sorry, I went too fast there. So you get to that 4 hooked together like that. Any of you who might have had chemical straightening or perm, there's some nasty smell stuff going on, that's a disulfide bond. That's permanent. And so on that level, they're breaking those quaternary bonds, reforming them, and then the neutralizing agent, and reforming them, and put them around a roller or straight, and then put it on again, and you have permanently changed that structure, that 3D structure of the protein of your hair. Sometimes it doesn't go well. Protein folding diseases. We have these chaperone proteins that we think help, and if they get all messed up, then things don't work well. One that we're seeing is mad cow disease. And we also know some misshapen proteins are with cystic fibrosis. All right, so I'll come back.